Okay, hello everyone. I welcomes to all in our lecture series on laser physics. In this lecture series, we are discussing these topics which are most essential for BSc, BTech, MSc, MTech and various entrance examinations. In our last class, we have been discussed basic properties or characteristics of laser and concept or principle of laser. In this class, we are going to discuss metastable state and population inversion. Okay, so let us start. These things already we have been discussed in our last class. What is the simulated absorption, stimulated emission, and population inversion? These things already we have been discussed in our last class. Okay, and we discussed in our last class that to achieve the continuous laser action from a system, we need population inversion, which is a necessary condition. That means number density should be large in the excited state as compared to the ground state, which is the so-called your population inversion. This is required, or you can say necessary condition to achieve a continuous laser action. So how to achieve this population inversion? For that, we have to consider a metastable state or a artificial state that we are going to introduce, which will provide the population inversion. How that we are going to discuss in this video. Okay, here you can see when we are going to apply some external energy by optical pumping. Suppose you have to consider the lower energy state atoms or molecules or electrons will excite to the higher energy level, but they remain in the higher excited state for 10 to the power minus 8 second only. After that they will transit to ground state by spontaneous spontaneous emission, right? So population inversion could not be achieved. Same thing I have been written. As we discussed previously, an atom remain in an excited state for approximately 10 to the power minus 8 seconds. After that, it emits photon and drops to lower energy state by considering the selection rule. So here why I have been written the selection rule? Because the selection rule is the rule which restricts or allow the probability of a transition between the two quantum states that we know. May you have been remembered, the selection rules are written as like this: del L equal to plus or minus 1, del ML equal to 0 plus or minus 1, del J equal to plus or minus 1. So here this is nothing but your L is nothing but your angular momentum quantum number or azimuthal quantum number. This is your magnetic quantum number. Magnetic quantum number. This is your angular momentum, and this is the total angular momentum quantum number. So suppose you just consider this one, del L equal to plus or minus 1. That means if this upper level L value is 2 and lower level L value is 1, then the atom or molecule will will easily or allowed to transit from higher to lower. Otherwise it will restrict. So the selection rule will restrict or allow the transition from one state to another. So what I explained here, suppose here difference between the two level, L difference of L, if plus or minus 1, here in this case plus 1, 2 minus 1 is your 1. So if it is so, then the atom and molecule will transit, allow to transit. Otherwise it will restrict. Okay, so here you just imagine this higher energy level E3 having the L equal to 2 and lower energy level having L equal to 1. So here the selection rule will be equal to plus 1. That means it is valid or allowed, the transition allowed. So only for that spontaneous emission will happen, or you can say after 10 to the power minus 8 second, the atoms are in E3 level will transit to ground state followed by this selection rule through spontaneous emission and emit the light, emit the photon. But these photons, these due to the spontaneous emission, these photons could not provide the laser action because they are not in the streamline or they are not in the phase. So due to the spontaneous emission, we can get the normal light, right? But if we can create the population inversion, whatever we have been discussed in our last class, then by external photon, the upper atoms will be stimulated and they will transit by stimulated emission and we can found the laser action. So we need the population inversion to perform the stimulated emission. Emission instead spontaneous emission. Okay. Now here, if these two levels follows the selection rule, then they then the upper atom will easily transit, or you can say the upper atom will transit through the spontaneous emission, right? If these two level could not follow the selection rule, then what will happen? Then the EG transition from upper level to lower level will be restricted. So the EG transition, or you can say natural transition, or you can say spontaneous transition from upper level to lower level will be restricted. If it will be restricted, then the upper level atoms or molecules will be retain some extra time in the upper level. Then we can found the population inversion. Then we can get the chance that we can get the population inversion. So our aim is that the atoms and molecules has to spend longer time then population inversion होने की chances है. There is a chance that we can get the population inversion. Okay, so for that what we done here, we introduced a artificial state nearby upper level in between the two energy level E1 and E3, another artificial state or the so-called metastable state here introduced. Same thing I have been written. Just imagine if an intermediate or artificial state will be created or introduced just below higher level, then atoms will transit to that state by non-radiative transition and spend more time, around 10 to the power minus 3 seconds, because atom could not able to get the chance to follow the exact selection rule. As the result, population inversion, that is your n2 greater than n1, will be created between artificial state or your metastable state and ground state. So here I am going to explain what is the meaning of this. Already I discussed. Here you can see the E3 and E1 followed the selection rule, that is del L equal to 1. So easily transit happens, or the spontaneous transition happens from E3 to E1. Only for that we could not get any type of population inversion. Here another metastable state introduced just nearby E3. So here the atoms at upper level, they are not going to transit straightly from E3 to E1. So they will transit most of the atom, not all the atom. Some of the atom they can transit from E3 to E1, but most of the atom transit from E3 to E2 with a non-radiative transition. Non-radiative, just remember, non-radiative, not radiation, radiative, non-radiative. That means there is no light energy. You can consider thermal energy. By radiating thermal energy, they transit to E2. So here E3 and E1 followed the selection rule del L equal to 1. If we are going to introduce a metastable state or another new artificial state just below the E3, obviously these two energy level could not follow the selection rule as del L equal to 1. So here the atoms or molecules which are transit from E3 to E2 with non-radiative transition, here they could not follow the direct selection rule between E2 and E1. So if they could not follow the direct selection rule, between these two levels. That means they will spend some extra time in this state, or you can say in this metastable state. So when they will spend the extra time in this state, we can achieve the population inversion in between these two states. These two states. Okay, same thing I have been written in your note. Okay, here this artificial state is called the metastable state, and the system with population inversion is okay. So population inversion in this way it will achieve like this. See, the atoms will spend around 10 to the power minus 3 second in the metastable state, because they could not follow the direct selection rule I written over here, exact or direct selection rule. Only for that they will spend the extra time or more time in E2, due to which we can achieve the population inversion between E2 and E1. And any system which follows this population inversion, or system with population inversion, is called as your active system. That means the system is ready to provide the laser action. Okay. So this is the non-radiative transition, whatever I told. From here to here, whatever the transition will happen, that is your non-radiative transition. So here I am going to stop our today's discussion. In our next class, we are going to discuss difference between spontaneous emission and stimulated emission. Here, these are the points. You can get this question around 3 mark in your exam. 3 to 4 point is enough. In detail, we are going to discuss in our next class. Okay, thank you so much for watching this video. Thank you.